Hi mathematicians, in this problem it is asking what problem is represented by the model. And so as you can see from the arrows, you can see that you've got one red chip that was placed into the problem space, and you've got, this time we finally have a yellow chip as opposed to all of our other ones before, that also was placed into the problem space. And you know that the red chips equals -1, so that means that a -1 was placed into the problem space, plus we know that the yellow chip represents a +1. Well, what happens when a -1 and a +1 get together? So remember on our number line, so let's say I start right here at -1. If I move over one place to the right, because that's what +1 would mean, right? So if I move over one place to the right, that gets me to 0. So if you have a -1 and a +1, they basically cancel each other out in order to give you a 0. Imagine, the negative number, like let's say you owe somebody $1 and somebody gives you $1. What you should do is take that $1 and pay off the person you owe, right? Well, at least if you do the right thing, I think anyway. So a -1 plus a +1 is equal to 0. So the way that we will type it into the answer space here, let me zoom in, it'll be a -1 plus a +1 is equal to 0. And remember to make sure that there are no spaces. In this next example, you can see that two different groups were added into the problem space. So you've got the green rectangle that represents this group that was put into the problem space. And then you've got the purple box that represents that group that was put into that problem space. So you've got two different sets of chips that were placed into that problem space. The first set, you've got 1, 2, 3, 4 red ones, which we know is -4. Over here we have 4 positive chips that were placed in there. So we know that's a +4. And then you can see that each pair of chips, so those two right there, for example, are circled together. And notice how that pair cancels each other out, just like the previous example. And this pair were circled to show that they were kind of grouped together, and that +1 and that -1 will cancel each other out. These two are going to cancel each other out, and those two are also going to cancel each other out. That is why whenever you have a positive and a negative chip next to each other, that is called a 0 pair, because you've got a pair of chips that cancel each other out to make 0. So exactly what problem is represented by what we've got here? So you had a -4 and a +4 put together into the problem space. So that would be -4 plus +4. And when you combine them, you get a total of 0. So if we want to type them into the answer box, we're going to do -4 plus 4 is equal to 0. Remember to not make any spaces. Just leave it, or else it won't quite count it correct. And in this last problem, you can see the way that it's grouped, and you can tell I'm trying to get you used to seeing problems done a little bit differently, because depending on who makes the problem, sometimes you've got a box to surround it, sometimes you've got lines, sometimes arrows, all kinds of different things. So what's happening here is that in the group surrounded by the blue, we added 1, 2, 3, 4, 5, 6 yellow, which we know is a +6. And then in the group surrounded in pink, we added 1, 2, 3, 4, 5, and those are negatives, right? So that's going to be a -5. So that's kind of a messy 5. So the problem is +6 plus -5. And remember, typically, not always, but most of the time, whenever we've got a plus and a minus back to back like that, we want to go ahead and put parentheses around it in order to make it a little bit more clear to read. So what is going to happen when that 6 and that -5 get together, when they combine? Well, let's say that one and that one will cancel each other out. That one and that one cancel each other out. Each positive and each negative form a 0 pair that will cancel each other out. And then what is left over? There is going to be one positive left over that didn't have a negative to cancel it out. So a +6 plus a -5 is a +1.